In this problem, we're going to use Thevenin's theorem to find V0. And the way we work with Thevenin's theorem here is we're going to remove the load from the circuit. In this circuit, it's a 4K because that's what voltage V0 is across. So we're going to remove this element from the circuit. We're going to find the Thevenin equivalent of the remaining part of the circuit. Then, once we have the Thevenin equivalent circuit, we're going to come back in and we're going to hook up the 4 kilo ohm load to the Thevenin equivalent circuit and calculate V0. So our procedure here will be, let's remove this, let's find the open circuit voltage, and then we'll calculate the Thevenin resistance. We'll hook the 4K up to the Thevenin equivalent, and that's how we'll find the voltage V0. So first, let's remove our load from the circuit, which is a 4 kilo ohm resistor. So here's our circuit for calculating the open circuit voltage. So we've removed the 4K resistor from the circuit, and if we go through and look at analyzing this, basically we have a single loop circuit. Let's define a current I1, and then if I apply KVL, I'll have 6K I1 plus 3K I1 minus 12 minus 6 equal to 0. So I have 9K I1 equal to 18, and that tells me that I1 is equal to 2 milliamps. Now, with I1 equal to 2 milliamps, that tells us the voltage across this resistor from Ohm's law has this polarity, and it has a value of 6. Now, in the circuit, since we have an open circuit, the current flowing out here is 0. So the voltage across this resistor is 0. So now, to calculate VOC, all I have to do is apply Kirchhoff's voltage law around this loop. So when we do that, we get VOC is equal to 6 minus 12, and that's minus 6 volts. So we remove the 4 kilo ohm resistor. We found the voltage. The terminals A and B, we remove that 4 kilo ohm resistor. We found the open circuit voltage. Now we're going to find the Thevenin resistance. And for that, we're going to take this circuit now, we're going to turn these two voltage sources to 0. So we're going to turn this one to 0, this one to 0, and really 0 volts is characteristics of a short circuit. So when we do that, here's our circuit for finding the Thevenin resistance. So if we note here, these two resistors are in parallel in series with this one, so our Thevenin then is 2K, and we have the 6K and the 3K in parallel, and that gives us that the Thevenin resistance is 4 kilo ohms. So now we have the Thevenin equivalent circuit. We found the Thevenin equivalent resistance is 4 kilo ohms. The open circuit voltage is minus 6. Now, we're going to hook up the 4K to this. The voltage V0 is the voltage across there, and we can calculate V0 by voltage division. So V0 is minus 6 times 4K over 4K plus 4K, or minus 3 volts.